Okay, so in this video, we're going to investigate this transformation, which is f of x plus a. Now, it looks really similar to this one, f of x plus a, but I'm hoping you can spot the difference is in this one, the plus a is being added on afterwards, whereas in this one, the plus a is being added on to the input. So in this case, this time it is the input that is affected, or that is changing. So we've got to be really careful about what's going on with this. If you haven't watched the first video, I described this function that I made up, and these were the original table of things that we've got here. So the example I'm going to look at is I'm going to try and draw the transformation or describe the transformation of what happens to the original graph when I change it to y equals f of x minus 2. So what this means now is for the input, my inputs are all decreased by 2. Let's see if we can figure out what they might be. Now I've changed the numbers up here, and you'll see why I've changed the numbers in just a second. So let's start at this end of the table. If I wanted to put 5 inside this function, well, I don't have information about 5, but before I do that, 5 is the value of x, and that means I'm putting 5 here. So instead of actually finding what the function of 5 is, I'm finding out what happens when I put in 5 minus 2. And 5 minus 2 is 3. So I'm actually finding out what happens when you put 3 inside this function. Well, we know what happens when you put 3 inside this function here. When you put 3 inside this function, you get 0. And likewise, when you put 4 inside this function that you've got here, you're not actually putting 4 in, you're putting in 4 minus 2. So you're actually trying to figure out what is f of 2. Well, f of 2, we can see from the graph here, is minus 2. And similarly, f of 3 will be the same as f of 1 because we're subtracting 2 from it. And f of 1 is also minus 2. So you're going to end up with this table kind of replicated, but the difference this time is that the input values for x are actually 2 bigger. Even though it's got a subtract 2, we're actually putting in values that are 2 bigger to get the same outputs as before. So this would be like f0, this would be like f of minus 1, f of minus 2, and f of minus 3. And that helps it a little bit easier to see this minus 3 up to 3 is corresponding to this part that we've got here. So the outputs will be the 1, the 3, the 1, the 1, the minus 2, the minus 2, and the 0. Now when we plot this graph, I'm not going to be plotting the minus 3 and the 1, the minus 2 and the 3, because if you do, you're literally just going to end up with this same graph as before. So the things that I'm going to be plotting will be the 5 and the 0, the 4 and the minus 2, etc., etc. So I'm going to start with this end because that's sort of where I seem to have started before. So the 5 with the 0 would be over here. The 4 plots with a minus 2. The 3 plots with a minus 2. The 2 plots with a 1. The 1 plots with a 1. The 0 plots with a 3. And the minus 1 plots with a 1. So it doesn't matter if you can't fill in the whole graph, we're just going to do the ones of the information that we've got here. So connecting these together, I have these here. And I'm wondering if you can spot what has happened here. From the blue one to the red one, every single coordinate has shifted across 2 positions. Every single coordinate has shifted across 2 positions. It's not that easy to see, but if you look at each coordinate, every single one has moved 2 places across. So it looks like it has shifted across a translation, and it has gone 2 spaces to the right and nothing up and down. Well, that's weird because it had minus 2 here. Minus 2 here might have made us think, oh, I know what's going to happen. It's just going to move 2 spaces to the left. But that doesn't happen. It doesn't move 2 spaces to the left. It does the opposite of what you think, and it moves 2 spaces to the right. If it was a positive 2, it would be going 2 spaces to the left. But because I have a negative 2 here, it is moving 2 spaces to the right. Okay? So let's think about what would happen to the coordinates. All of the x coordinates are going to increase by 2, even though it says minus 2. It kind of does the opposite of what you might think. So the x coordinate so the minus 3, 1 is going to change, and it's going to become minus 1, 1. And actually you can see that in action here, because the minus 1, 1 was originally the minus 3, 1. So I'm going to add 2 onto this x coordinate. I'm going to get 3 minus 2, and I'm going to add on 2 to this coordinate, and I'm just going to keep the y coordinate the same here. So this is the hard part. If it has a minus with it, it's going to move to the right, which is kind of not what you'd expect. And if it has a plus with it, it's going to move to the left, which is normally the direction we associate for negative things. So what might this look like algebraically? Well, we're talking about the input is changing now. It's no longer an input of x, it's going to be an input of x minus 2. So it's not going to be sine of x minus 2. That would be representing f of x minus 2 with the subtract 2 happening afterwards. Instead, the input needs to change. So I'm going to open up some brackets here, and I'm going to say that I'm not putting x inside the sine function. Instead, I'm putting in x minus 2. And we're going to have a look at what happens to this quadratic this time. This time I've got an x plus 1. A plus 1 is actually going to translate the graph 1 to the left. So it's going to be moving 1 space to the left. I'm going to replace every time that there is an input of x. I'm now not going to be inputting x. I'm going to be inputting x plus 1. So I'm going to have x plus 1 squared plus 2 brackets x plus 1, and then that 3 at the end doesn't have an x with it, so it's just going to stay like that. If you wanted to, you could very quickly expand these brackets so that you come up with something like this, and then you could simplify the whole thing so that you get x squared plus 4x plus 6. That would be a translated version of this, but this is perfectly good to have as well. So if you have f of x plus a, it actually is going to represent a translation, and the translation does the opposite of what you'd think. It's not going to move a spaces to the positive direction, it will do the opposite, so it will go negative a. So this one kind of does the opposite of what you would expect. Had minus 2, it moved 2 spaces to the right. We'll do some examples with these later on. We're just getting the theory of this to begin with. So let's have a quick look at Desmos to see that in action. So I've got this with x plus b. It doesn't really matter if it says a or b. I just needed a different letter for this. Now b is going to become positive, and you will see the red graph is going to move to the left. So when I, better turn it on first. Let's start with it at 0. Okay, so when it's a negative number, it's moving to the right, and as b is becoming a positive number, it moves to the left. So when b is a negative number, say negative 2, you can see it's moved 2 spaces to the right, and when b is a positive number, say that b is equal to, 3, you can see that the whole graph has shifted 3 spaces to the left. If you're finding it a bit overwhelming looking at all of the graph, just concentrate on one of the coordinates on the original graph and see where it is on the new graph that you've got there. Okay, so in the next one, we are going to be having a look at what happens when you put the negation inside the input. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.